Hello everyone, welcome back to the channel. My name is Nitin Kohl. In this video, I'm going to show you how to build a real PolicyDesk AI assistant using new Azure AI Foundry Agent capabilities. This is not a PowerPoint only session and it's not just theory. We'll actually build the agent, configure instructions, connect enterprise policy documents, enable knowledge grounding, test policy-based responses, validate citations, and see a complete working solution in action. Along the way, you will learn how Azure AI Foundry Agents combine instructions, enterprise knowledge, and guardrails to create reliable business AI application. Let's first take a quick look at the overall architecture and what we are building together in this hands-on demo. This is hands-on Azure AI Foundry build, not a graphical only architectural demo. We will create and run a real chatbot frontend, build a local FastAPI connector, deploy a model, create a new Azure AI Foundry agent, attach a policy knowledge source, and test the complete flow with real questions. We will show the difference between the base model and the new agent, what changes after grounding, and how the agent refuses questions outside its enterprise policy role. Like an employee asks a question such as what approvals are required before using a third-party AI model with confidential data. The assistant does not answer from a general conversation alone. It is configured to answer from approved enterprise policy documents through Azure AI Foundry. The final application flow is chatbot frontend, local FastAPI connector, which is backend, new Azure AI Foundry agent created in this video, agent instructions and knowledge source, Azure AI Foundry, grounded policy answers, chatbot. The local FastAPI application is only the connector for this real hands-on demo. The AI behavior, model, policy knowledge, grounding, and agent configurations are handled in Azure AI Foundry. Application flow trust is browser frontend, backend, policy, Azure Foundry, where we have model, agent, logging, content safety, cost cards, etc. Before we start building, let's quickly look at what you'll learn in this hands-on Azure AI Foundry agent demo. By the end of this video, you'll understand how to build real enterprise AI assistant called PolicyDesk using the new Azure AI Foundry agent capabilities. We'll start by creating a new Azure AI Foundry agent and compare it with standard model deployment so you can understand why agents are becoming the preferred approach for enterprise AI application. Next, we configure agent instructions. This is where we define how PolicyDesk should behave, what type of questions it can answer, and how it should respond when it does not have enough information. After that, we'll connect the enterprise policy document as a knowledge source and enable knowledge grounding. This allows the agent to answer questions using approved company content instead of relying on only general model knowledge. We'll then compare grounded and non-grounded responses so you can clearly see the difference between a generic AI user and an answer backed by enterprise policy document. We'll also explore prompt boundaries and agent guardrails. You'll see how the agent follows its instruction and why users cannot simply override its role by asking it to ignore its configuration. Next, we'll test how policy handles out-of-scope questions instead of acting like a general purpose chatbot. It will stay focused on enterprise policy topics and decline unrelated requests. We'll also look at source citation and references so users can see exactly which policy document supports a response. Finally, we'll put everything together in a complete end-to-end demonstration and test the working PolicyDesk AI assistant in real time. On the left side of the diagram, you can also see the application flow we'll be using in this demo. A user asks a question through a browser. The request goes through a FastAPI connector. Azure AI Foundry processes the request and the PolicyDesk agent generates the response. And on the right side, you'll see how enterprise policy documents are connected to agent through knowledge grounding, enable trusted responses with source citation. So if you are ready to learn how to build a policy-aware enterprise AI assistant with Azure AI Foundry agent, let's get started. We are starting with the product experience. This is the chatbot that an employee will use. At this point, the front end is not connected to AI. The interface is real, but the backend connection is not yet complete. This is the code. This is the user interface for our PolicyDesk AI assistant. Its responsibility is intentionally very simple. Collect a user's question and display the response. One important thing to notice is what is not present in the code. There are no Azure AI credentials. No API keys, no connection strings, no secrets, and no direct access to Azure AI Foundry from the browser. From the security perspective, that's exactly what we want. The browser should never contain sensitive configuration that could be exposed to end users. When user submits a question, the front end simply sends that request to our backend API endpoint. The browser acts as the presentation layer while the backend handles the integration with Azure AI Foundry. You can see in the code that the front end calls a local FastAPI endpoint rather than communicating directly to Azure AI Foundry. This creates a clean separation of responsibilities. The front end focuses on user experience, the back end focuses on business logic, security controls, and Azure AI integration. And Azure AI Foundry provides the AI capability that powers the assistant. For this demo, I intentionally kept the front end lightweight because the objective is not web development. The goal is to understand how Azure AI Foundry agent, instructions, knowledge grounding, and enterprise AI components work together to deliver trusted policy-based responses. So think of this web page as a secure and simple entry point where users interact with the PolicyDesk AI assistant, while the actual intelligence and enterprise control resides behind the scenes in the backend and Azure AI Foundry. The assistant has a clear name, PolicyDesk Assistant. The status indicator tells us whether the backend is connected. This is important because a user should not be shown a successful AI experience when no AI request has been actually happened. So this clearly says that we will get response when backend AI is connected. Like it clearly says the backend could not complete the request, check the API is running, and Azure settings are configured. This first step teaches an important application principle. Build a user experience separately from AI connection. It also prevents us from confusing a visual prototype with working AI system. Now we create a small application connector. It is a local fast API service for this hands-on demonstration. This is not the API platform. It is a bridge between the browser and Azure AI Foundry. This is our backend connector code. This fast API service sits between the browser and Azure AI Foundry. The browser never communicates directly with the AI model or the PolicyDesk agent. Instead, the front end sends the user question to backend using post/ask endpoint. The backend then processes the request, communicate with our saved PolicyDesk agent in Azure AI Foundry, and returns the answer to the browser as a simple JSON response. This backend layer is important because it gives us a control boundary between the public-facing user interface and Azure AI service. When a question reaches the connector, Pydantic validates the request before it is sent to the agent. The question cannot be empty and its maximum length is limited to 2000 characters. The response is also written through a defined structure containing an answer field. This keeps the API contract simple and predictable for the front end. The application also applies its shared question validation logic before selecting a model or making a network request. In other words, the input is checked before it reaches Azure AI Foundry. After validation, the backend uses the Azure AI project client to connect to saved PolicyDesk agent. This distinction is very important. The backend is not calling only the base model deployment. It is sending the request through saved agent created during this demonstration. This allows the request to use agent's configured instruction, attached knowledge source, and defined behavior. If you bypass the agent and call the base model directly, the model could respond using general knowledge without following PolicyDesk instruction or using the connected policy documents. Authentication and secret. Just like the front end, the backend source code does not contain a hard-coded API key. For local deployment, configuration is loaded from the backend environment, including the Azure AI project endpoint and saved agent name. The local .env file remains on the server side and should not be committed to the source code. The connector uses Microsoft Entra ID authentication through default Azure credential. This is just for the demo. In real enterprise environment, we create this backend service inside Azure Cloud and use managed credentials where human ID is not involved. During this local demonstration, the connector can use the developer identity already authenticated through the tool such as Azure CLI. This means the browser never receives an Azure credential, identity token, project endpoint, or direct access to the Foundry service. All Azure authentication happens inside the backend process. FastAPI defines the API endpoints while Unicorn runs the API locally on port 8000. The /health endpoint provides a simple way to verify that the backend service is running, and /ask endpoint receives policy questions from the front end. CORS is enabled, so the local browser application can call this backend during the demonstration. For convenience, the demo currently permits all origins, but in production implementation, that wildcard should be replaced with the exact proved front-end origin. So the purpose of this Python code is not to make the Python lesson. Python and FastAPI are simply being used to implement the application connector. The connector gives us control place to receive requests from the browser, validate user input, apply application level controls, authenticate to Azure using a server-side identity, call the saved PolicyDesk agent, handle errors consistently, return a predictable response to the front end. If you need this code, please comment and I will update this in my GitHub and provide the link. See, the intelligence still comes from Azure AI Foundry Agent. Its instruction, its model deployment, and its connected enterprise knowledge. The backend simply connects all those components together securely and exposes them to our PolicyDesk user interface. The connector also needs to know which Foundry project and agent to use. Those values are configuration, not application logic. The live connection is Azure AI project endpoints and Azure AI agent name. When we actually create agent, we'll note these two downs and then update in our environment file. Let's use Python virtual environment. Go in your required directory. Let's activate our virtual environment. Let's install prerequisite. So basically we are setting the second one, the connector. I already have this installed, but for demo purpose, I executed it again. I activated the virtual environment first. This keeps the project dependencies separate from the rest of the computer. Because I am running the backend locally, I use Azure CLI to sign in as the developer. The chatbot user is not logging into the Azure. This login is used by the local backend through default Azure credential. But in the real enterprise application, you cannot use your personal login. So application is hosted inside Azure and managed identity is used where you don't have to log in. So the application, front-end application will talk to backend using managed identity, and then using that managed identity, it will talk to Azure Foundry. Now let's start our server. That means our backend server is running. The health response only proves that FastAPI is alive. It does not yet prove that the Foundry agent can be called. Now let's build our model and then save it as agent. I am inside my project, which is set up in US East. If you see here, if you directly try to build agent, it will not give us option to select mod. But for this demo purpose, let's make it simple. Let's first set our model and then save it as an agent. Deploy base model. I want mini 5.4 mini. If you see here, our input requirement is very basic, text, maybe images. When you select default setting, it will not give you option to use name what you want. So let's set up custom. Let's give name PolicyDesk GPT 5.4 mini. Let's select global standard because of cost effectiveness. Let's keep everything default. Deploy. Our model is built. This is our model with all default settings. Like we can directly use this model, but thing is that for persistent system instructions and all, you need to use that or pass into your front end. You need to set those instructions in your front end and pass it here because there is no option here to save inside the model. You can only save this as agent and then use it, and then it can be persistent. If you're using direct model, this endpoints or key, it will work, but it will not be persistent system instruct. Like for example, in this case, without system instructions and all, it's like open. There is no restrictions, nothing. And if you type like, basically it will answer anything because there is no restrictions. But in our demo, we cannot use this thing because we don't want anything hard coded and pass it in our front end. We want mostly everything to be set up inside our AI Foundry, and with these new options as an agent, everything can be set up. So let's save this as an agent. Here we'll give same name. Let's give PolicyDesk demo. Create. Now if you see, Our model is this, and it has a version 1. Now we can use this agent. Now if you see no system instructions, nothing. So this will behave same like open-ended. You ask anything, it will try to answer. But we don't want that thing to happen, and we want to make this agent behave as a policy desk. So let's put system instruction. Now this agent is our reusable Azure AI configuration. So we can update instructions, make changes, and save it. Let's update system instructions. Clearly we are telling him your only purpose is to answer questions about the connected enterprise policy documents. Do not act as a general purpose chatbot. If the user asks about identity, decline. Also do not use general model knowledge. Clearly we are saying is that decline anything which is not provided in our enterprise policy and make it politely. We can test it here. These are not instructions coming from user. They are the saved instruction for assistant. The user question is input to the assistant. It is not allowed to replace the assistant role. After changing the instructions, let's save and let's start a new conversation. See, it clearly says I can only answer questions about a connected enterprise policy documents, and it will not respond to anything else. Now we need to use this connections in our backend. If we go here in details, if you click here, you will see the code. This is our endpoint. This is the agent name, and agent version is version 2, which is the latest. So let's update this. In our environment, for a backend connection, we updated the project endpoint, the agent name, version, and then the isolation key. So we exactly have to match what is present here. Let's save it. Confirm. GUI will test it so that we 100% that this agent is set up as required. It cannot provide that data. Before you use this in our backend or even try to use it in our front-end application and backend, let's manually validate if we can connect to our backend agent and everything is working, so that we are 100% confident that our newly agent build is working fine. Let me log in. This confirms that I have logged in. Let's confirm if token can be obtained. It says that we can retrieve a token. Let's stop this and restart it. Our backend server is running. Let's test our API before we test in our browser. We got response from our AI model. That means our connection is fine. And at this stage, we have not provided any documents and all. That's why it's saying that it cannot answer anything because it doesn't have any reference to any documents. This confirms that from my desktop, I can connect to the backend new agent which we created. Now let's test our front end. It says backend not connected. So when we type any prompt, it should try to connect to backend. Nice. So if you see from our front end, using our backend connector, using those API endpoints, it has connected to AI Foundry, connected to our agent, and retrieved the data. It clearly says that I can only answer questions about the connected enterprise policy documents. That means our full flow is working from front end to back end to Azure AI. Presently, it's working. Let's try different prompts. Okay. Okay, let's try the last one. So our system instructions are working. PolicyDesk assistant is working or behaving exactly as we required. The next thing is grounding. Let's upload our documents. I have created 3 dummy policies like AI model governance policy, data classification, and third party. These are dummy documents which will provide to our agent as a grounded document. See, instructions tells the assistant how to behave. They do not contain all of the organization's business knowledge. For that, we provide approved policy documents through the Foundry knowledge workflow. These are synthetic demonstration documents. Each document is structured with stable section identifiers such as D.1, C1, so the assistant can point to the precise source. I'm in Foundry. Let's upload these documents. Let's attach them. See, we're not writing any local Python document search engine. The policy documents are uploaded into the Azure AI Foundry knowledge workflow. Foundry handles the connected source and grounding path. Let's test the same prompt. Inside our GUI, it provides answers from our data provided. Let's use the same one in our front end. To save it, and then it will work. See, now it clearly gets data from our latest updated saved agent configuration files. I asked what standards, if there are any standards defined for data if I need to travel outside country. This is perfectly working as a PolicyDesk enterprise assistant. Before this knowledge source was attached, this was acting as a general model interaction. The difference is grounding. The model is now answering with the connected policy content instead of relying only on general knowledge, which is what any enterprise requires. The local connector records only operational metadata like deployment agent, success or failure. It does not record any API keys, any intra tokens, any sensitive prompts, any sensitive retrieved documents. Let's summarize the final design. The front end is the user experience. The local FastAPI service is the application connector. It receives the HTTP request and forward a question to agent. The Azure AI Foundry agent owns the AI behavior, contains the instruction, the connected knowledge source, the grounding behavior, and the selected model. The policy documents provide approved business content. They are not a general conversation dataset. The agent must stay inside its role. User prompts cannot replace its instruction. Unrelated question must be declined. If the connected policy source does not answer, the assistant must say so. The most important lesson is this: a production AI assistant is not just a model endpoint. It is a controlled application built around model. Today, we build and explain an enterprise policy assistant using Azure AI Foundry. We created a real chatbot frontend. We connected it through local FastAPI application connector. We configured the saved PolicyDesk agent in Azure AI Foundry. We added policy knowledge and demonstrated grounded responses. We tested out-of-domain questions and confirmed that assistant does not behave like a general chatbot. We explained Azure identity, agent instructions, knowledge grounding, source reference, safety. If you found this demo helpful, please like the video and subscribe the channel. If you have any questions, drop them in the comments and I'll reply. And if you want a demo on specific Azure AI topic, suggest it below. Thank you and see you in next demo.